Hi, here is group 5, and this I'm Yuqi Zhang.
I'm Yuxin.
This is our PowerPoint for the Physics 114 project.
Okay, let's start. Question 1. The consequence is to prevent the thread from slipping on the eyeball during the pendulum motion caused to the failure of the experiment. Question 2. The pivot point of the pendulum should be the point where attached to the thread with eyeballs. Question 3. As you can see from the picture, is when the ball at initial position. We use the paper ruler to measure x, and we measured that the paper ruler is 20 cm from the pivot point, so we can use tangent to calculate the release angle. Question 4, The benefit is that we can get a smaller angle and we will get the pendulum length and period easier to make the experiment more specific. Question 5. The thread has a certain elasticity. Also, we may touch the thread when we measuring the length caused to an arrow. And question 6. Sorry about that. To provide a standard and is convenient for the following measurements. Question 7. We use the thread 1.05 meter to establish the scale factor, which we already measured before the experiment. Question 8. The ball has two forces, gravitational force, which is pointing down, and the tension of the thread on it, which along with thread. Question 9. As you can see from the picture, for the axis, the equation is mg sine theta equal to max. For the y-axis, the equation is ft minus mg cosine theta equal to may. Question 10. The centripetal force is at y-axis, so we use the equation on y-axis, so for the tension. Question 11. I expect when the ball at bottom, which is 0 degree from vertical, the thread tension is maximum. The reason is when theta equal to 0 degree, the cosine theta is maximum, so the tension is maximum. Question 12. We could find the speed of the ball by conservation of mechanical energy. The following is the equation: mgh initial plus 1/2 m initial velocity square equal to mgh plus 1/2 mv square. Question 13. This one is the same as last question. The only difference is that the height was no longer 0. Question 14. LogPro uses the slope of x position and y position to get x velocity and y velocity.
Because slope of x position and y position is x velocity and the y velocity. Also, we're using v speed equal vx square plus vy square, square of them. And question 16. For the theta, we do not use the sine one. We use more difficult but more specifically one is arctangent. We use arctangent. We use theta equal arctangent of x position over 1 divided by 1.5, which is our radian, is the line long, and then gets the y position. Because the system in the local pro is radian mode, so we need to change the radian mode to the degree mode. That's why we times 100 degrees over pi. And for the question 17, because acentripetal is equal to v squared divided by r squared, and we put our r is named line, and that was 1.05 meter. And also we already built the v speed part, so just use the square v speed to divide by L. And then question 18 is talking about percent error. So for percent error, we need to find the data of the mass, which in the ideal condition. That means it's very exactly on that part. So we find the data in the test is F equal 0.0944 Newton, and in the mass is F equal 0.0942 Newton. So we get the error is smaller than 0.01%, is 0.0021%. In the 19, first we need to find the acentripetal. So we using the equation which we find at question 9 to calculate that. And then we got the then we know the mgh is equal to 1/2 mvf squared minus 1/2 mvi squared. That means we can use this function to get our vf squared. Then we can get the vf is equal to 0.34. So for the first function equation I said, we can get ft is equal to 0.0156 Newton. Then in question 20, it's same way to question 19, but different number. So for this one, we need to carefully because it's in the elevator, so the G is not equal 9.8, is equal 6 times 9.8. And also from using same way to calculate that, we get Vf is equal 2.051 meter per second, and Ft is equal to 0.5653 Newton. And there is our group project. Thanks for your listen and watch. I'm Yuqi and
Yuxin.